Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0532 indicates a low voltage issue in the AC pressure sensor circuit for the Honda Accord from the years 2012 to 2017. This code is crucial as it relates to the performance of the air conditioning system, affecting overall vehicle comfort. The AC pressure sensor is responsible for detecting refrigerant pressure changes, which is essential for the air conditioning system to function efficiently. When the air conditioning load is low, the sensor outputs a low voltage and high voltage during high load. The Powertrain Control Module, PCM, essentially the vehicle's computer, monitors these voltage signals to ensure that refrigerant pressure remains within acceptable limits. If the sensor's output voltage is below a specific threshold for a certain duration, the PCM registers a malfunction and sets this DTC. Proper understanding and addressing of this code can lead to effective troubleshooting and resolution, ensuring a well-functioning air conditioning system, vital for driver and passenger comfort. To prevent future occurrences of DTC P0532, implementing a routine preventive maintenance schedule is beneficial. This schedule should include regular checks of the air conditioning system to ensure it is functioning efficiently. During these checks, it's important to inspect the AC pressure sensor and associated wiring for any signs of wear or damage that could lead to future issues. Ensuring that the refrigerant levels are adequate can also help maintain the pressure within optimal parameters, preventing undue stress on the system. Moreover, consider cleaning electrical connections to minimize corrosion, which can impede electrical flow and cause voltage issues. Proactive measures like these can significantly extend the life of the AC system and reduce the likelihood of encountering similar diagnostic trouble codes in the future. In summary, understanding the role of the AC pressure sensor and its connection to the overall air conditioning system is fundamental when addressing DTC P0532. By following a systematic troubleshooting approach, effective diagnosis and repair are achievable. Each step, from checking the ignition switch to inspecting wiring and the VCC line, gives an insight into the potential causes of low voltage signals and ensures thorough analysis of the situation. Preventive maintenance recommendations will serve to mitigate future issues, significantly enhancing the longevity and reliability of the air conditioning system. Ultimately, addressing this DTC not only contributes to superior comfort in the vehicle, but also improves operational efficiency. By remaining vigilant to symptoms and maintaining the integrity of system components, one can ensure the optimal functioning of the vehicle's air conditioning system. The AC pressure sensor plays a critical role in managing the air conditioning system's performance by measuring the refrigerant pressure. It is located in the AC lines, usually near the compressor, where it can accurately gauge refrigerant pressure as it circulates. This sensor is connected directly to the PCM, providing crucial data to adjust refrigerant flow and optimize climate control within the vehicle. When the air conditioning system is under low load, the sensor typically emits a lower voltage signal, while a higher load results in increased voltage output. The PCM interprets these signals to determine whether the AC system is functioning as intended. If the sensor outputs a voltage of 0.24 volts or less over a defined period, this prompts the storage of the DTC P0532, indicating malfunction. Understanding each component's location and function is vital to effectively diagnose and repair this issue. Several factors can lead to the DTC P0532 being triggered. Firstly, an AC pressure sensor failure can occur due to internal damage or wear, rendering the sensor incapable of providing accurate voltage signals to the PCM. Secondly, a short circuit to ground in the PD sensor line can also result in low voltage readings. This is often caused by damaged wiring or poor connections within the AC harness. Thirdly, an open circuit in the VCC line, which supplies power to the AC pressure sensor, will result in the sensor being unable to function properly. Thus, it cannot relay the necessary information to the PCM, leading to this DTC. Lastly, a failure within the PCM's internal circuitry can also trigger this code, although this is rarer. Thorough inspection of each of these potential causes is necessary to ensure accurate diagnosis and repair. The symptoms associated with the DTC P0532 can directly impact the functionality and comfort of the vehicle's climate control system. Typically, one of the first symptoms drivers may notice is a malfunction of the AC system itself, where it may fail to produce cold air or exhibit inconsistent temperatures. As a direct result of the AC system not functioning efficiently, the cabin temperature may rise, leading to discomfort for both the driver and passengers. Additionally, the vehicle may indicate low refrigerant pressure, which can sometimes lead to further issues if not addressed. In some cases, a persistent low voltage reading may cause additional strain on the vehicle's electrical system, leading to further degradation of components. Awareness of these symptoms can help in the timely diagnosis and resolution of the underlying problem indicated by the DTC. The first step in troubleshooting the DTC P0532 is to verify that the ignition switch is in the on position. This ensures that the necessary power is supplied to the vehicle systems, including the AC pressure sensor. For vehicles with a conventional key system, simply turning the key to the to position is sufficient. If the vehicle is equipped with a keyless access system, the on mode must be engaged using the start-stop button. This ignition state is critical, as any misplacement of the key or failure to start the vehicle properly can prevent accurate testing and monitoring of the AC pressure sensor. Any inconsistencies at this stage can lead to false DTC activation, making it essential to confirm that the ignition switch state meets the requirements outlined in the diagnostic data. Upon verifying that the ignition is set correctly, the next step involves investigating whether there are any active diagnostic trouble codes, DTCs, present in the vehicle system. This can be done using a qualified scan tool, which will provide insight into the status of all stored DTCs. If other DTCs are active, they may need to be addressed before tackling the P0532, as they could influence or disguise the actual issue. If the DTC list includes multiple codes, it's prudent to clear the stored DTCs and then take the vehicle for a short drive. This helps to reset the monitoring system, allowing for accurate observation of the AC pressure sensor's performance under normal operating conditions. Clearing the DTCs can ensure you're not chasing historical problems that may no longer be relevant, allowing for a clearer diagnosis. Next, it's essential to conduct a thorough inspection of the AC pressure sensor itself and its associated wiring. Begin by locating the AC pressure sensor, often situated along the refrigerant lines, and visually examine for any signs of damage, corrosion, or loose connections. Faulty wiring or connectors can lead to erratic signals sent to the PCM and could be the cause of the low voltage reading. If any signs of wear or disconnection are apparent, repairs or replacements should be performed as necessary. Additionally, using a multimeter, check the voltage readings being produced by the sensor itself during operation. These readings should align with expected parameters defined by the manufacturer. This step is crucial as it allows for verification of the sensor's functionality and ensures that the PCM receives accurate data for effective climate control system management. After verifying the AC pressure sensor and its wiring, the next step involves checking the VCC, or Voltage Common Collector, supply line, that provides power to the sensor. Using a multimeter, ensure that there are no broken connections or interruptions along this line that could inhibit power delivery to the sensor. If the VCC line is open or shorted, it will prevent the AC pressure sensor from operating correctly, leading to the PCM detecting a low voltage situation. This failure in the VCC supply will trigger the DTC P0532. Careful inspection and testing of this circuit are essential to confirm that voltage is reaching the sensor as expected. If issues are found in the VCC line, repair or replacement may be necessary to ensure the system returns to optimal functionality. Performing this check diligently also aids in isolating the root cause of the problem effectively. Once all necessary repairs have been conducted following the previous troubleshooting steps, it is essential to verify that the repairs have effectively resolved the issue. Start by testing the AC system to ensure that it is functioning correctly and producing cold air under various load conditions. Monitor the AC pressure sensor to confirm that it is now providing accurate voltage signals to the PCM. This can be done through a diagnostic scan tool or by using a multimeter to check the output of the sensor while the system is operating. Additionally, ensure that no DTCs return after the repairs, indicating that the problem has been resolved. If the DTC P0532 has been cleared successfully and does not reappear, this shows that the underlying issues have been addressed adequately. Such final checks are vital for assuring vehicle performance and center around ensuring a comfortable cabin environment for driver and passengers alike. Please like and subscribe to the channel. See you next time.